Hello and welcome to the next project in our Prodigy pathway at Code in the Schools. This project is going to be about building an FPS game. And in this simple FPS game, we're going to focus on styles more like Call of Duty or different assorted like Modern Warfare games where you are a first person shooter game, right? Now, ours is going to be much more basic so that we aren't spending too long on it, but we're going to cover a lot of the basic concepts that go into this. Now, as you'll see in the lesson area in the classroom, there's no activity guide with this lesson. Instead, I have a bunch of references listed under the assignment. Now, if you ever get confused, I want you to reference the references. These are the areas where I feel like we're going to run into issues, and if you need help with the code, I want you to reference the video as we build this out together and look over what I have pre-made, right? At the end of class, I'm going to challenge you to use some of these concepts we talk about to make a character controller. But what we're also going to do is we're going to use concepts that we went over in our last project, the rollerball. Now you do not need to have done the rollerball lesson if you're approaching this now on your own time, but I would encourage you to do that first if the option arises. Anyway, let's begin. So as you can see in front of you here, I have my scene. I have a pill-shaped player. And then I have just a very basic ground and some objects set up so that we can demonstrate how this camera works, right? Now, when we think of looking first person, right, really that camera is going to exist in the head of the player. So as you look at this scene here, I want you to try to build it at home. And I'm going to talk about different parts of it, right? Now, we have a plane at the bottom, just like our last. If you right-click in your hierarchy, you can find that in 3D Objects, Plane, and I spread out the X and Z axes to make it much larger. Also, you can see I have a capsule, sorry. I have a capsule made here for the player. Now, it doesn't need to be a capsule. It can be a cube. It can be whatever you want. Just make sure it's kind of a shape that is taller than it is wide. And that's going to just help you out with the feeling and with the impression that you're going to have to build upon with this controller here. Because we're trying to mimic human movement. If we were making some sort of alien, we'd be mimicking alien movement. But let's start here. Um, Now you'll notice that I have my main camera as a child to my player object, right? This is so that we can. Now, I guess I downloaded something there. My bad. Anyway, this is so that our camera can see out of our player, but nothing can see in. What do I mean by that? Well, if you've noticed, if we go underneath of our plane here, I can see right through, right? The mesh renderers only go one way. So as long as our camera lives inside of our capsule here, it's going to be able to see everything on the outside from the inside. Then we can also use that camera as a reference point to rotate the character, look up, look down, and still be inside that desired area, that head area that our character would be seeing, right? So start to build out a scene similar to this, start to put a plane down, build out a capsule. On that capsule, add a rigid body, make sure it has a collider, right? Attach your main camera to your player, name your capsule player and tag it player, name your ground, name every object in your scene, just so we stay organized and we don't lose our place, right? And make sure everything kind of looks like what I got going on here. And I'm gonna give us a minute or two here to do that. Uh, I know I kind of rambled there a little bit. The intention was to give you more time. And again, for those who don't know, if you go in your hierarchy and you right click, You go to 3D objects, so you can find every object we have in here. So there's cubes, there's a capsule, there's a plane. You don't really need to worry about quads, trees, ragdolls. We'll go over those eventually. But for right now, just worry about these 5. Sweet. So now that you have that, we're actually not going to jump right into coding, but I want to talk about something very specific to Unity that we are going to utilize when it comes to uh, everything here. Well, what shape do we use for the ground? Okay, so on the ground, you're going to use a plane. So I'll get rid of my ground and show you. So in the hierarchy, we're going to right click, 3D object, and then plane. It's the 5th one down. When you hit plane, you'll get a flat plane like this. It should look like a square in a 3D world. And by that, I mean it's one-dimensional. One side of it will collide, the other side things will pass through. You're going to want the hard side up. And then once you have this here, what I like to do is go into my transform, go to scale, make X10 and Z10. And that's just so that we have plenty of space. Because towards the end of class, we might make like a simple movement script to work with everything we got going on. Alright, I'll double check. Is it another question? No, okay. Anyway. Continuing on. Alright, so now continuing on, let's talk about something called inputs or controls. If we go to the edit tag right here up at the top left next to file, and we go all the way down to project settings, you can find yourself in this menu here, and you're going to want to go to input manager. I'll do that again for those of us at home. Edit, down, under selection, under sign out. You want under selection, you go to project settings right here. Leave my screen there for a hot second. And then in project settings, you're going to click it and then navigate to input manager, which is the 4th down. And then don't edit anything. Let me check the classroom once again. Okay, cool. Cool, David. No worries. Just keep on trying. Anyway, so one more time, just to make sure people see it, we're going to edit, we're going to project settings, and then we're going to go to input manager. Now that we're input manager, you'll see a whole lot of things like axes, horizontal, vertical, fire, jump. All of these are the controls that we would normally use inside of a game. These are the stereotypical ones that Unity has pre-built. You can even make your own, right? But let's take a look at horizontal and vertical, and we're just looking at them. We're just trying to understand them. We're not doing much else with them, right? So don't edit anything in here, please. You'll see the name is set to horizontal. They didn't really give it a description or anything. Now, its negative button is set to the left arrow key, and it's positive to the right. It also has A and D set to negative and positive, right? This lets us use both our arrow keys and our WASD keys by calling one thing. And this is going to be get axis that we're going to be calling in our code later. You can see it has a whole bunch of different physics assigned to it, right? And the same for input manager. I want you to understand that this is where we're pulling these from. And you can do this with a whole bunch of other things. You can do this with the fire mechanic, with jumping, with your mouse X and mouse Y, which is something we're also going to be using. So, this being said, we're going to take this and we're going to then go into our code and begin working on our looking script, right? Now, I haven't even shown you what this looking script does, and it doesn't seem too great until we have our controller in yet, but I can use my mouse to look left and right. I can look up and down all over, and then my character falls over because I don't have any constraints on the players. So I can even do that now and go rigid body, constraints, and then I wanted to be able to do all that, but I don't want it to rotate against the Y, I believe. That was incorrect. Y and Z. Alright, absolutely no rotation whatsoever. Yeah, and for right now, that'll work. Right? But we can see as you can look up and down, left and right, it's a little jerky, and I think that's because I have the rotations turned off. But I don't want the character necessarily jumping around so much. We can also control the sensitivity of that in our camera. So if we want it to be super sensitive, I actually prefer 200. But you can see how that goes. And then we fall over because we don't have a movement script on it yet, but that's fine. Either way, we have that movement script. Now we're going to jump into our codes. So as we've done before, we're going to go into our projects tab. We're going to go in our assets folder. We're going to right click, create a new folder, and call that folder scripts. Once you have scripts made, we're going to go in there and then we're going to make a new create C# script. We're going to name that like looking controller or mouse controller, right? Something along that lines. Once you have the name, and remember your name should have a lowercase word at the beginning, absolutely no spaces, never add a space, and then a capital letter for the second word. Alright, and then we can open that up, except I'm going to make a new one and talk with you about each bit here. Alright, so we pop over here, look at this. We need sensitivity, a transform, and a rotation. What does all that mean? So, let's start off with our variables, right? We want to control the sensitivity and how much the mouse is affected when we move. Correct? So what we're going to do is make a public variable for that. We're going to do a public float, and I'm going to call this sensitivity. And then, once we have that, we're going to want our player model to actually move when we move right to left, not up to down. So we're going to need to differentiate that. A good way of doing that is calling for just the transform of our player object since we're in the child right now. So we'll do public transform. player transform. And then finally, we're going to have the X rotation. And I'm going to set that to private X rot for X rotation equals 0f. X rot does not exist, so private float, sorry, my bad. Private float X rot. Awesome, awesome. Now, let's start making our function here. So we're going to do void look with mouse. There. Let me zoom in here for you so that I'm not going all crazy on you. So we have our look with mouse script. Now we can start our look with mouse script by getting our X and Y inputs, right? We're going to use get access for that. You see input.getAccess here, right? The reason we have our sensitivity is so that we get a either greater or sorry about that. So that we get either a greater or lower value depending on all of that. What do I mean by that? Well, if our sensitivity is say 200, what our X or Y axis is going to return is going to be so little. When we multiply by 200, it'll be like a reasonable number. But let's say we want our sensitivity to be really low. We want our player to only move a little bit along with our mouse. Well, then what we're going to have there is we're going to get a smaller number altogether out of these floats mouse X and mouse Y because our sensitivity was lower. It's just basic multiplication. Higher number equals higher number, lower number equals lower number. It's because we're multiplying a decimal by whatever number this is. So let's write this exact thing, but over here together. So we're going to go float, name it something like mouse X equals, and then we do input dot get access, and then let's check my spelling here. Mouse X, doing this correct. I need that to stop popping up. Yep, I did that right. Mouse X times sensitivity. And then we're going to also multiply it by time.delta time. And as we went over, that keeps it in line with the frame rate, so that the speed at which it's moving is in sync with the frame rate of our game. Awesome, awesome. So now we're going to be good and efficient coders and just copy this entire line of code. Once we have this line of code copied, you just paste it below. And then we're going to change anywhere where it references X to Y. Now, why are we making it all Y? Well, we need to get the Y value as well. And all the calls are exactly the same. Super simple, super easy, and that's really the route you want to go when it comes to coding. So as we move from there, what we're going to do is we're going to do something called clamping our code. Now, clamping is a math function that makes it so that no matter what, the value is going to fall between two numbers, right? So here we're taking our X rotation and we're making sure it falls between negative 90 and 90, and it never goes above that. That locks it at 180 degrees. This is so that when we go looking and we look up, we don't break our character's neck by going in through the back of the head, right? We want to stay in some sort of reasonable space. So you can look all the way down and then you can look all the way up, but that's about it. Your head will not twist back like you're some sort of monster from a horror movie. So to do that, we have to do everything here. We have to take our X rotation and subtract our Y from it, right? And this will help us with positioning. And then we have to clamp our X rotation. So let's do that real quick. That is just a straight math F. And there we go. We have that bit of our code written. Now, finally, we want to do something with this number. We want to make our guy move, right? So when it comes to the camera itself, we want it to rotate left and right, or not left and right, up and down. So we'll do that here with transform that local rotation, right? Local referencing itself, whereas a world rotation would reference the entire object in reference to the entire world. Now you can find more about this in the references section and go to local rotation. And you can even navigate from local rotation to rotation and then world rotation. So sorry about that. Rotation is broken up into a few different parts. And what we use this for is to either manage the rotation of an object in reference to itself, in reference to other objects, or in reference to the entire world's 0, 0. Right? Local is in reference to itself, and that's what we need here. So we're going to change its local rotation with quadridian Euler, which just sets a rotation. That we're just creating that and setting it. And then we're going to use the rotate function here, which will actually already use time.delta time. And we're going to rotate along its up vector, right? Which actually, if you think about it, it's taking a line or a pin and dropping it right in the top of our character. And it's saying rotate around this, right? That's why that's not the x. That's why that's not a different variable. We're rotating around the up. So when we multiply by that, or when we use that and we multiply by it, that's what we're rotating around. So let's take this and rewrite it in our code over here. So transform dot rotation equals quadridian dot Euler, and again, all this does is set up a new rotation, and then we have our player body that needs to rotate now, and we just call that first. So it's player transform dot rotate, and rotate is a function that's pre-built. We take a vector 3 dot up and multiply it by mouse x, and now this whole thing should be functional as soon as we go to update and we add look with mouse, and then we have one other thing we need to add. You might have noticed me zipping by it in here, but we have cursor.lockState. This makes it so that our cursor disappears while we're in our game, and it locks our cursor to exist inside of our game world. And it's just a Boolean. It's either locked or unlocked, so we're going to set it to locked here, and we do that in our start. So it's cursor.lockState equals cursor lock mode.locked. All right. So I'm going to zoom out a second so you can see everything. And then in just a second, I'm going to move to going back into our code. All right, cool. So now that we have all that written, let's go back into our code. All right, give it a second to load. But you're going to take your script. I already have my script attached, so I'm not going to really use this one, but you're going to take it, and you're going to drag it over, and you're going to attach it to your main camera, right? That should be your main camera is attached to your player, your script is in your main camera. You scroll down, and you'll notice that your script has two different things it's looking for, a sensitivity, and then a player transform, and this should be empty. To get your player transform, you're going to grab your player object and just drag it over into there, and then that'll fill that up for you. As far as your sensitivity goes, set it to 100, set it to 200, whichever really works. I will check that question. All right, I'll help you out at the end of the class, and we'll get that sorted out, okay? Cool, cool, cool. So, once you have that player transform dragged in over there, you can hit run and be able to look around your game using this new code that you've written. All right, so with that being said, that is what we're going over today in class. I know that seems simple, but I have a challenge for you at home that I want to see you try to do before next class, and that is use the horizontal and vertical inputs that we saw earlier that take either arrow keys or A and D and give you back a number. And I want you to use that to make a script that will move your character around and will use your mouse controller or looking controller script in conjunction to have a fully movable player. All right, so try that. At the beginning of next class, I'll talk about how I do it. All right, and let's see what you get. All right, so with that being said, thank you for showing up to class today, and I'm going to hang out to answer any questions.